Welcome to DC Circuits online lecture, DC standing for Direct Current Circuits. The learning objectives are a review of symbols, looking at Kirchhoff's laws, looking at resistors in series and in parallel, and redrawing complex circuits. So let us begin with a review of the symbols. A long line and a short line represent a dry cell, a rectangle represents a resistor, a cross in a circle represents a light bulb, and a circle with a squiggle represents an alternating current source. A V in the center of a circle represents a voltmeter, an A in the center of a circle represents an ammeter, and an arrow in the center of a circle represents a galvanometer. Crossed wires with a dot are connected as a joint or node, crossed wires with a jump are not connected, an arrow represents a variable connection, and this represents a switch. Let us now move on to Kirchhoff's laws. He has two of them. Kirchhoff's first law states that at any node in an electrical circuit, the sum of the currents flowing into that node is equal to the sum of the currents flowing out of it. This means if the I1, I2, and I3 are flowing into a node, I4, I5, and I6 are flowing out, then the sum of I1, I2, and I3 is equal to the sum of I4, I5, and I6. So in general, the sum of currents flowing in is equal to the sum of currents flowing out. Next, Kirchhoff's second law states that the sum of EMF around the loop is equal to the sum of potential drops around the same loop. This means that if a circuit has E1, V1, E2, and V2, then E1 plus E2 is equals to V1 plus V2, and in general, the sum of EMFs is equals to the sum of Vs. Let us now learn to find the effective resistance of resistors that are placed in series and in parallel. Let us first find the effective resistance of resistors placed in series. If we had resistors R1, R2, and R3, then the effective resistance would be R1 plus R2 plus R3, and additional resistors would just be added to the sum. So the effective resistance of resistors in series is simply the sum of their individual resistances. Now on to resistors in parallel. If I had three resistors in parallel, R1, R2, and R3, then the reciprocal of effective resistance is the sum of their reciprocals. So the reciprocal of the effective resistance is equals to the sum of the reciprocals of the individual resistors in parallel. Let us now learn to solve effective resistance in complicated looking circuits. I will be teaching you two methods to do this. For the first method, we will solve effective resistance by looking for series, then parallel, then series, then parallel resistors. Here's how it's done. Take for example this complicated looking circuit with 5 resistors. Their resistances are 6 ohms, 6 ohms, 5 ohms, 6 ohms, and 6 ohms. These two resistors are in series, and therefore I can add their resistances. Then these two resistors are in parallel. Hence we find effective resistance by summing the reciprocals of their resistances. Now these two resistors are in series, so we can sum up their resistances. And finally, these two resistors are in parallel, so we sum up their reciprocals. The second method involves redrawing the circuit. We will draw everything horizontally. The nodes will look like this, and lastly, get plenty of practice. Let us look again at the circuit we just used. Instead of numbers, I am going to label the resistors A, B, C, D, and E. So I'll put this circuit on the top half of the screen for comparison. Starting from the first connection, we see that it branches off into 3, with resistors A, C, and E. Continuing with the A branch, we see that it continues into B. Continuing from B, we split into 2, connecting into D and back into C. And then from D, we split into 2 again, finishing into the final connection and also connecting back to E. This still looks a little messy, so let's clean it up a little bit. I'm going to move the final connection down in line with the first connection. I'm going to move D down, and I'm going to redraw the initial branching out to look like this. This new circuit diagram allows me to clearly see which resistors are in parallel and which are in series. So we have reached the end of the lecture. Again, the learning objectives were a review of symbols, looking through Kirchhoff's laws, looking at resistors in series and in parallel, and finally redrawing complex circuits to find effective resistance. We hope that you have enjoyed this online lecture, and we will see you in tutorials.